Ever felt like your brain just shuts down when you hear the words quantum physics? What if I told you that in the next 5 minutes, you'll not only understand it, but you'll also see how it's running your entire life? Stick around, because this is going to get weirdly awesome. The famous scientist Richard Feynman once joked, "If you think you understand quantum physics, you don't." That sounds pretty intimidating, right? But here's the secret. While it's strange, we actually understand a lot about it. In fact, without quantum physics, you wouldn't have your computer, your phone, or even the sunlight warming your face. It's the hidden engine of our world. So, what is it? Quantum physics is the science of the absolute tiniest things in the universe: atoms, electrons, and particles so small they make an atom look like a planet. And down at that tiny level, the rules of reality get bizarre. We're used to thinking of things like electrons as little specks, like microscopic marbles. But in the quantum world, they can also behave like waves, spreading out like ripples in a pond. Scientists describe this with something called a wave function. Instead of saying, "the electron is right here," they have to say, "well, there's a certain probability it's here. Or maybe over here, or even way over there." It's a world of possibilities, not certainties. It's like the universe is constantly hedging its bets. Now for the coolest, most mind-bending experiment of all time. Imagine you have a wall with 2 slits in it. If you fire paintballs at it, you'd expect to see 2 splatters on the wall behind, right? One for each slit. Simple. But if you do the same thing with electrons, something incredible happens. You don't get to simple splats. Instead, you get a whole pattern of stripes, like the interference pattern you see when 2 sets of water waves cross over each other. This proves the electron acted like a wave and went through both asterisk slits at the same time. But here's where it gets even crazier. If you put a little detector by the slits to see which one the electron goes through, poof, the wave pattern disappears, and you just get to splats, as if the electrons were particles all along. The very act of looking at them changes their behavior. This is the measurement problem, and it's a mystery that still keeps physicists up at night. This leads to 2 famous quantum ideas. First, superposition. This means a particle can be in multiple states or places at once until you measure it. It's like a spinning coin that's both heads and tails until it lands. The second is entanglement, which Einstein called spooky action at a distance. You can link 2 particles together in a special way. And no matter how far apart you take them even across the galaxy, what you do to one instantly affects the other. It's like they have a secret, instantaneous connection. And the weirdness doesn't stop. Quantum physics allows for something called tunneling, where a particle can literally pass straight through a solid barrier it shouldn't have enough energy to cross. It's like throwing a tennis ball at a wall, and instead of bouncing off, it just appears on the other side. This sounds impossible, but it's happening constantly. Without quantum tunneling, the fusion reactions inside the sun couldn't happen, which means no sunlight, no warmth, and no life on Earth. There's also a fundamental limit to what we can know. It's called the uncertainty principle. It says you can't know both the exact position and the exact speed of a particle at the same time. The more precisely you measure one, the less you know about the other. It's not a limit of our tools. It's a fundamental rule of the universe itself. Finally, why the name quantum? The word quantum just means a specific amount or a packet. In an atom, electrons can only have certain fixed energy levels, like steps on a staircase. They can't exist in between. When an electron jumps down from a higher step to a lower one, it releases a little packet, or quantum, of light called a photon. So even light comes in these discrete chunks. So let's recap. Tiny particles are also waves. They can be in many places at once. They can be mysteriously connected across vast distances. They can tunnel through walls. And we can never know everything about them simultaneously. It might sound like science fiction, but this is the reality that powers our world. So next time someone says quantum physics is too complicated, you can tell them, it's weird, it's amazing, and it's the reason your phone, your computer, and even the sun all work. Thanks for joining me on this journey into the bizarre. If this blew your mind, hit that like button, subscribe for more, and let me know in the comments, which part of quantum physics do you find the most fascinating? See you next time.